There we go. It's brighter now. Alright, so today's notes are very much connected to yesterday, which makes sense because they're part of the same section. Alright, and we use the factors to find zeros, and we use zeros to graph. And we're just doing a little bit of graphing. From factored form, we can find the zeros using the zero product property, which we used back in chapter 5, so it should sound at least a little familiar. And the way this works is that to find the zeros, we're going to say that y equals 0. So when we rewrite it, it'll say 0 equals x minus 2, x plus 1, x plus 3. Anybody remember how we use this to solve quadratics? How the zero product property played into it? Very carefully, all right. What we said was that if things multiply together to get 0, at least one of them has to equal 0. So we use that to say, well, then x minus 2 equals 0, x plus 1 equals 0, and x plus 3 equals 0 at some point on the graph. So solve each of those. So I'm going to add 2 to both sides. X equals 2, subtract 1, x equals negative 1, subtract 3, x equals negative 3. So those are my zeros for this function, which also means x-intercepts. So you can go over to your graph and mark those spots. So negative 1, negative 3, and positive 2 as your x-intercepts. And remember I told you that cubic functions like make an S shape. So you can, it doesn't have to be perfect, but you can just sketch a graph through there. What I'm going to be looking for on your homework is 1, it's not a straight line. Okay, it shouldn't be a straight line. And 2, that you've got your zeros correct. Okay, so the zeros need to be exact, but as far as like the shape of the graph, it's just a sketch. You can put it in the calculator so you can see the shape of it if you want, if that'll make you feel better. Go for it. But make sure your zeros are exact. Any questions about that? No? Please put your iPad away. All right. Now we can reverse this process to write the linear factors when we have the zeros. That's opposite of what we just did. That almost looks good. So that last problem, we started with the factors and ended with the zeros. So now we're going to go backwards. We're going to start with the zeros and end with the factors. The relationship between the two, the linear factors and the zeros, is called, described by the factor theorem, which is down below in the shaded box. Factor theorem says the expression x minus a is a linear factor of a polynomial if and only if the value a is 0 of the related polynomial function. Okay, let's break this down. So what it's saying is that x minus a is a factor, and so that makes a 0. So if you have the factor, you can find the 0. Now, this statement is actually two-way. You can, if you have the factor, you can find the 0, or if you have the 0, you can find a factor. We know that by this phrase right here, if and only if. That means that we can reverse the statement and it's still true. Not all theorems are that way. Some theorems are just one way. Okay, if something's true, then something else is true, but that doesn't necessarily make it the other way around. If you ever take a class that has lots of theorems, so like science or math class, sometimes they write if and only if, like this, with two F's. So that tells you that the statement goes both ways. Just a little tidbit of information that I find interesting. Okay. So let's use it to go backwards. We're starting with zeros. We have -2, 3, and 3, and it wants us to write a function in standard form. So we know that x equals -2, x equals 3, and x equals 3, all when y is 0. So we can use that to write our function f of x, and each of those will give us a factor. So x equals -2. Let me zoom in here. If we wanted to work that backwards, we could add 2 to both sides, and this right here is your factor. So our factor is x plus 2. Okay, so what would the next one be? X minus 3, and the last one's the same. So there, now we've got the start of an equation. And this step is what's new. Everything after this we did yesterday. So now we're trying to get it in standard form, which means no parentheses, combine all the like terms, and put it in order of degree. So let's start by foiling these first two sets of parentheses. So I'll have f of x equals x times x is x squared. X times -3 is -3x. 2 times x is positive 2x. And 2 times -3 is -6. And then I still have x minus 3 in parentheses behind all that. Next, let's add like terms. So x squared minus x minus 6 all times x minus 3. From here, we will distribute more. Okay, so x squared times x is x cubed. X squared times -3 would be -3x squared. Okay, so I took care of x squared. Now multiply -x by the two things in the back. So -x times x would be -x squared. -x times -3 would be positive 3x, because that double negative. And then last piece is -6 times x is -6x. -6 times -3, positive 18. Our last step is to combine like terms and make sure everything's in order. So what will come first? X cubed. Okay, took care of that. What next? We can combine our x squared pieces. So -3 and -1 make -4x squared. And then combine your x pieces. So 3 and -6 make -3 x, and then plus 18, and you're done. Yeah. So Jalen pointed out that, hey, one of the zeros happened twice, and that happens. So this little starred thing talks about that. Polynomial from example 5 has 3 zeros, but it only has 2 distinct zeros, -2 and 3. When a linear factor is repeated, the zero is also repeated and called a multiple zero. So multiple zeros you describe by like how many times they happen, and that's called their multiplicity. So in that example, the 0, 3 has a multiplicity of 2 because it happened twice. So I'm pretty sure this example number is wrong. I'm not exactly sure what it's supposed to be. Probably like 6 or something like that. In these problems, they ask you to find any multiple zeros and state the multiplicity. In order to do this, we need to factor. So maybe make note that that's what you're supposed to do. So, what do we have a greatest common factor? X squared. Okay, so divide everything by x squared so we can bring it to the front. So we get x squared times what?
X squared plus 6 plus 8.
Yeah, very good. So in order to figure out the zeros, we need the linear factors. We're not down to linear yet, so let's figure that out. I'm going to make my big X. What goes in the top?
8.
Uh-huh.
And
then 6.
Yep.
Yeah, 4 and 2, multiply to get 8, add to get 6. So I have my fractions. What's in the denominator? 1 because of the A. Both those are reduced. So I have just got 2 factors, x plus 4 and x plus 2. Now we need to bring the x squared down, but we're trying to make everything linear, right? X squared, as x squared, is quadratic, but what can we break it down into?
X plus
X times x. So we can have x and another x. And if I'm trying to find my zeros, set it all equal to 0. So I'll have x equals 0, x equals 0, x plus 4 equals 0, x plus 2 equals 0. Simplify the last two. X is -4 and -2. So how many zeros do I have?
4.
4. How many distinct zeros do I have? 3. -2, -4, and 0. So which one is my multiple zero? 0, and what's its multiplicity? 2. Multiplicity of 2.
And that's how many numbers there are? Yeah.
Yeah, how many times it happens?
So like if there was like 4 zeros, you'd say multiplicity is 4?
Yes, which can happen.
The 0?
The 0 is, so it said find any multiple zeros. So I wrote down my multiple 0 and stated its multiplicity. If you want to write it out, 0 is a multiple 0, then you can. That's all. One thing I want to point out to you, just to make the connection here, what was the degree of this? 4. How many zeros did it have? 4. Up above, what was the multiplicity of this one, or the degree of this one? 3. How many zeros did it have? 3. Notice the pattern there? Yes. Okay, any of these that you want to see in the calculator with multiple zeros, you can. I'll just tell you that, like this last one, the zeros were at -4, -2, and 0. So what happens is the multiple zeros, that's when your graph changes direction. So it like goes whoop, back up. So the regular zeros, it goes through. Multiple zeros, it changes directions there.
Oh, that makes sense.
Okay. We're gonna have to graph.
Wait, what?
You only have to graph the first 3.
It's when
If it has
the,
4 zeros?
The multiple zeros, the graph changes directions at that point.
the
Instead of just going
aspect-
straight through it,
Okay.
it switches and goes the other way.
So it's all multiplication
What's that called?
Yes.
Zero.
axis?
Axis. There, I was like Aztec something.